Okay, before I start the assignment, I want to go over a couple review problems. You guys solved the inequality graph, your solution. Remember, inequalities have an infinite number of solutions, which you represent with the number line. Okay, so first thing, I only have the single variable, single x variable on this side. Now I've got to spot the multiplier or the divider. Multiplier, -2. That means the sign is going to switch. Okay. Why? Well, because I eventually have to divide both sides by a negative. So plus 4, line up the sign when you add or subtract, so you get -12 and then -2 times x. Then you divide by -2, divide by -2. So you actually come before the symbol. I think it does, so you need to put it before the symbol, and that's 6. So I got 6, circle, don't fill it. Does it open towards the x? No, it doesn't. Okay, doesn't open to x. So that means you go this way. So x is any number less than 6. Okay, next problem. Got to apply the distributed property, of course. It's 50. By the way, some people on the assignment, not stupid enough to say who in a published YouTube video. 15f, you got to take 3 times 3, 2. Okay, that's 9. Okay, we got f's on opposite sides. Fortunately for us, they're both the same, so they can be canceled. Makes this an easy problem. So we got 9 and 9. Now normally that's all solutions if it says equals, but since it don't say equals and the bar isn't there, that's a no solution, because 9 is not greater than 9. That's a ridiculous statement. Okay, compound inequalities. You have 2 inequalities in the same problem. There and there. So we're going to make a table. On one side, this middle part of the sign is circled twice. Okay, whatever's in the middle is overlapped. So on one side you got -1 less than or equal to x minus 3. Over here you got x minus 3 less than or equal to 2. Okay, well, I don't have to worry about my sign switching because x is here. It doesn't even have a multiplying or a dividing number, so the sign will stay the same. So we add 3, add 3. Guys, x comes after the symbol, so you have to put it after the symbol. So -1 plus 3 is 2. Okay, don't have a multiplier, don't have a divider. Okay, so you're going to add 3. You don't have to worry about the sign switching. Add 3. I mean, you could put a 1 if you want, but it still is positive. So x is by itself. X is before the symbol here, so you got x, 5. Now you plot those numbers on the number line, 2 and 5. So you'll fill in both circles. Question, does it open towards x? Okay, it does, so it goes this way. Even though it's a less than sign, it opens towards x, so it has to be going the greater than direction from 2. Okay, here it does not open towards x, so it's back the other way. Remember how you write that. X, 2 on one side, 5 on the other. Opens to 5, and then it opens to x, so it has to open to x. Okay, there you have it. Okay, next one, another compound. It says or, so it's easier to set up than when it's in between the two like that. 2x less than or equal to -4, or 7x greater than or equal to 49. Okay, so over here you got x. It has a multiplier of +2, so the sign doesn't change. So we divide by 2, we get x, -2. Multiplier is 7. Sign doesn't need to change because it's a +7. Divide by 7. Divide by 7, you get 7. So -2 and 7 are the numbers I have figured out. Now which way do we go? Don't just connect them every single time. I know 2 years ago you did that, but not now, okay? Because I never put problems like this in Algebra 1. Does it open towards the x from the -2? No, it does not open up towards the x there. So from -2 we go that way to the left. Does it open towards x? Sure it does, so we go this way. So they go apart, they diverge. So you got x less than or equal to -2, x greater than or equal to 7. You just label them separately. Don't try to do it, don't write it like that, okay? there is a way to write it. One person I saw do that, and they did it correctly. Okay. Okay, now here's what your new assignment is today. Solve the inequality, graph your solution. Okay. Now we're talking absolute value, so think back to yesterday. So I kind of pay attention to the side the absolute value's on. Do I have any operations outside? Nope. So I go x, x. I'm not going to put equals though. Now you're going to put less than 5 because your less than absolute value less than 5 means don't draw this out. Okay, means if you're less than 5, that means you go in towards a 0, and that going that way is less than. But going less than 5, remember it's a distance. The distance goes less than 5. So to get that distance less than 5, I'm going the other way. Well, that's greater than. Okay. So I go -5, but then the sign has to switch. Okay. That's pretty well solved. Okay. You can go ahead and graph that. You have to graph it though, unlike yesterday because you just had an equals sign. So I go 5, -5. Now if ever there was a time to actually pay attention to whether it opens towards the x, it goes, remember, open toward x this way every time. Okay, I don't care if it's a less than greater. If it opens towards the variable, it goes that way. If it opens toward the number, we go back the other way. Okay, that opens towards a number right there. Okay, so if it opens towards a number, we go this way. Just make a little line. But the -5, it opens towards x, so we go the other way. So label that. Now you label it with x in the middle, -5, 5. With the 5, you open it towards the 5. With the -5, you open it towards the x. Okay. Okay, now let's talk about a simple greater than. So again, absolute value, make a table. You can write x down because that's what's inside, like yesterday. So nothing going on outside the absolute value, so I put 2, -2. Now I keep the sign on the 2, but I flip the sign on the -2. Okay? The reason, so that means we have an absolute value of greater than 2. So 2, to be a distance greater than 2, we go away from the 0. So that's a greater than direction. But to have a distance greater than 2 here, you go away from the 0, but we're going less than there, so we do switch it. Basically, all you have to remember is you switch it when you're on the negative. That's already solved, okay? So 2, -2, and 2. So let's talk 2. Circle, fill it in. Think it opens towards x, so it goes this way. Circle, fill it in. I don't think it opens towards x, so it goes left, okay? So they diverge. When they diverge, you just write the answers on each one, each step, because now they're separated. Okay, next problem. I see absolute value, you need a table. You need the expression x plus 8 on both sides. So no operations outside, so you can go 3, -3. Now you're greater than or equal to 3, but you're less than or equal to -3. For why we flip it, I just showed right there, okay? Because greater than 3 means they go outward, okay? So they go that way. The distance gets greater from 3. Okay, number line. First I better solve it. Okay, x, we got to get x by itself. It has no multiplier, so we don't have to worry about the sign switching. So we -8, and we get x, -5. Same thing, exact same process. Now it's -3 minus 8, -11. So we got -5, -11. Circle, fill them. Let's talk about the -5. Opens towards the x, so it is going this way. Does not open towards the x, so it's going the other way. So again, those are separated, they're not connected. Sometimes there we have it, okay? Don't just automatically connect them, you can't do that. You got to pay attention to opening. Okay, next one, number line. So we got x minus 2. Less than or equal to 1, but greater than or equal to negative 1. Because if I'm less than 1, then I'm coming in towards 0 from both ends. So going that way is less than true, but then coming in that way is greater than, which is why that happens. Okay, you don't have a multiplier at all, so guess what that means? Don't have to worry about that nasty sign changing. Plus 2, that's 3. Plus 2, that's 1. So 3 and 1 are your critical numbers. Open towards the x? No, it does not go that way. Open towards the x? Yes, it does. So it's going right. And those do combine. So x, you got 1, 3. Open the sign to the 3 and open the sign to the x. You open it to the same thing it is here. I mean, eating the same thing. Okay. Next problem. Okay, nothing going on outside that absolute value, so I got 2x minus 5, 2x minus 5, less than 9, greater than negative 9. Okay. Okay, we solve for x. We do have a multiplier, but it's positive, so that sign ain't going anywhere. So we add 5, that's 14. Divide by 2, that's 7. Okay. Add 5, that's negative 4. 2x, okay? The sign wouldn't flip again. If it didn't flip here, it ain't going to flip here because you still got the same multiplier. X, negative 2. So 7 and negative 2. Does it open towards, let's talk the 7. Does it open towards the x? No. It goes that way. Does it open towards the x? Yes. It goes this way. So x, negative 2, 7. Has to open to 7, and it opens to x, so it opens to x here, so we would switch that. So it opens towards the same thing here. It's a comparison. Okay, next one. Nothing going on outside, so we have 3x plus 1, 3x plus 1. 8, negative 8. Greater than 8, but less than negative 8. Okay, got to get x by itself. It has a multiplying operation of 3, which is positive, so right there. So when you're adding, subtracting, you need to drop the sign. So 3 times x, you can't just come down here. 7, divide by 3, divide by 3. Okay, now watch what I do. 7 divided by 3, I don't like that, so I'm going to go 7 ABC 3. 2 1/3. Just ABC it if you get a nasty decimal like I just did. Not any decimal, but an annoying one that goes on forever. Because that's going to look like crap. Okay, not going to flip. Minus 1, 3x, negative 9, divide by 3, and you get negative 3. So you have 2 1/3, negative 3. Let's talk about the 2 1/3. Opens to the x, going that way. Opens towards the number, going this way. Okay. So label them separately. X is greater than 2 1/3. X is less than negative 3. Okay, next problem. This one here can be a bear. There's one like that on the assignment. You only have 5 problems. Okay, number line. No. Okay, first we'll figure out the absolute value. So 4x plus 1, 4x plus 1. So you got 11, greater than 11, less than negative 11. Okay. Alright, so multiplier 4. It's positive, sign ain't switching. 10 divided by 4, that's going to be 2.5 or 2.5, x, 2.5, that's an x, okay? Same process here, just a different number over there. Divide by 4, I get x, negative 3. Okay, so the critical numbers are 2.5 and -3. Let's talk about the 2.5. Opens to the x, going that way. Opens towards the -3, it opens towards a -3, so it goes this way. When it opens towards a number I find, it goes the other way. So separate. Bam. Okay. This one here is a bear. So when I go set up my symbol and all that, I write x plus 2, x plus 2. Here's a problem. I think you got some operations outside there. Well, I know you do. You got a times and a plus. Now, when working with inequalities, okay, if you have a negative multiplier, which is that number there, then that sign's going to turn before we go to the table, because I will have to divide both sides by a negative. If that was +3, I would not be flipping it. It's all about the multiplier. Now I do what I did yesterday. First I subtract 4. So -3 times absolute value x plus 2 greater than -18. Again, I'm adding, subtracting, I just line the same sign up. Now it's dividing time. And that's 6. Absolute value x plus 2. Okay. Remember, if you have operations outside the absolute value and you got it greater than or less than, when the multiplier is negative, you still got to remember that sign flip rule. Now I'm good to go. Less than 6, greater than -6. So -2, that's 4. I don't have to worry about the sign flipping anymore because I don't have a multiplier. Same here. Okay. -2, x is now by itself, -8. So 4 and -8 are your critical numbers. Circle opens towards a number this way every time. That's a reliable rule to follow every time. Opens towards x, goes that way. So you get x, -8, 4. Open it to 4, open it to x, so it goes that way. Okay, then you got some cakewalk story problems. Okay, you have one story problem at the end. It's pretty easy. The ideal length of a certain that's poor wording, of a nail is 20 millimeters. The actual length must be within 0.4 of the desired size. Write an inequality that describes the range of the acceptable lengths of the nail. Okay. Here's how we set up a range. First we make a number line. This is like the only real life scenario I could figure out. But we're not going to put 0 in the middle. 0 is not part of the solution set. 20 is in the middle because that's what it's supposed to be. Okay? Now you make one on each side, and all you do with the 20 is you plus and minus 0.4. So 20 plus 0.4 is 20.4. 20 minus 0.4 is 19.6. Okay? So it has to be within that range. So it's going to be one of those where it connects. Okay, now use L for length. Okay, the variable L. So 19.6. If you used X, I wouldn't be mad at you. Okay. Now the highest number possible, the sign would open to that number. That's the lowest number possible, so we never open the sign to that number. Okay. And that's the answer, this thing here. Okay. If you can do that without the number line, fine. Okay. I don't even need the number line, I just need that. Okay, number line helps me visualize it. The ideal length of a horse fence is 300 feet. The length must be within 5 feet of the ideal amount. The ideal width is 450 feet. The width must be within 10 feet of the ideal amount. Write inequalities for the range of both the length and the width. So I'm going to do 2 here. Okay, length, width. 2 number lines because I have 2 answers this problem. This problem I only had 1. The length is supposed to be 300. Then I take 300 and I add and subtract 5. Well, that's easy. 305, 300. Or 295, my bad. 295. Okay, 295. Circle. You'll fill them in because you can be equal to them. and it's just in there. So I use L for my variable, 295 on this side, 305 on the other. We don't put 300 in the answer. Okay, we always open toward the maximum, but never open it to open the sign to the minimum. Okay, so that's the answer. Okay, width. Well, the ideal width is 450. So I do 450 plus 10 and minus 10. So it's 460 and 440. Okay. Writing really sloppy. It's pretty late here. Okay. So W, put the 440 on one side, put the 460 on the other. You always eat or open up to the maximum, but you never open it up towards the minimum, because that's not bigger than anything. Remember, it always opens up to the bigger thing. That's as low as we get, so that's why that's the answer. Again, if you don't want to waste time with this number line stuff, don't do it, okay? Okay, manufacturers curring metal into rectangles that are 20 inches long and 35.25 inches wide. Each metal's length and width must be within 0.25 inches of the desired size. Write inequalities that describe the acceptable range of the length and width. So I got to do length and I got to do width. So the ideal length's 20. Long means it's the length. The ideal width, 35.25. Okay, now we just use 0.25 on both of them. Okay, so it's going to be 20.25, and that's going to be 19.75. And same thing happens as before. So the answer to this problem is L, 19.75 on this side, 20.25 on this side. That's the big dog, so he has to open up. That's the little dude. Nobody opens up towards him. So, right there. 35.25, same thing. You're going to add the same numbers, okay? So I add 0.25, and that's 35.5 or 50. Minus 0.25, that's 35 even, okay? Again, this middle number I don't write in the answer. Okay, so I go W, 35, 35.5. That's the big dog. Always got to open towards him. That's the little dude, okay? Never open towards him. He's a little man on the totem pole. Okay, last one. The ideal circumference of a women's basketball is 28.75 inches. The actual circumference may vary from the ideal amount by at most 0.25 inches. Write an inequality that describes the range of the circumference of a basketball. So I'm only finding one answer here. Okay, so it's supposed to be 28.75, but it can vary by 0.25. So I add 0.25, and that's 29. I minus 0.25, and that's 28.5. Circle, fill, connect them. You can use C for circumference, okay, so 28.5. If it says length and width, I want you to use L and W, which is what the assigned problem is, 29. He's the big dog. Anything has to open up towards him. He's a little dog. Nothing opens up towards him. Okay.